Thank you, Kamil.
While developing our scientific software, we need to solve many architectural problems. And it seems that we like to use solutions of particular type. We like additive solutions. An additive solution is when we are adding something to what we already have. So for example, if we have problems with more and more new data, we might be solving those problems by adding new databases, using new database engines, adding new data models, new data formats, new naming conventions. If we are thinking about code, we might be adding new instances of our code everywhere else. We might be adding new R packages. Inside those new R packages, we might be creating and adding new exported functions. So we might be adding new application programming interfaces. And speaking of interfaces, we might be creating new dashboards for those new databases. And by adding those new dashboards, we might be adding new dashboard frameworks or new graphical user interfaces, or maybe adding new implementations of user inputs. So as a result, we might have multiple instances of almost everything. And there could be some serious consequences of overusing those additive solutions. We might suffer from fatigue syndrome. We all can suffer from this syndrome, although for different reasons. Our users might have this syndrome because they are tired of learning new interfaces, relearning old ones, learning new application programming interfaces, learning new graphical user interfaces, because there is higher cognitive cost of switching between those interfaces, and those new interfaces don't necessarily bring additional business or scientific value. But our developers might also have this fatigue syndrome because there are multiple maintenance problems, there are inefficiencies in development process. So why not to try subtractive solutions? A subtractive solution is a solution when we are solving a problem by removing something from what we already have. And the examples of those subtractive solutions in our context could be, for example, a single common data model. If our data are coming from the same domain, maybe this single data model is possible to achieve. Another example might be some shared standardized part of application programming interfaces. There could be some common interface for accessing those new data. There might be common graphical user interface shared across different dashboards. We might be thinking about modularizing our whole scientific software ecosystem and extracting components that are easily reusable across all our data products. But it seems that we have one huge problem here. And the problem is that we are biased towards those additive solutions. And a series of problem-solving experiments recently published in Nature revealed that we are more likely to consider additive solutions than subtractive solutions, even when subtractive solutions are more effective. And moreover, we are doing it not because we don't recognize the value of subtractive solutions, but because we fail to even consider them. And that's really disturbing. Imagine how it can impact our scientific software architecture if out there are some superior solutions that we could use to make our architecture better, but we miss them completely. So what are the reasons for that? Authors of those Nature papers suggested a number of reasons. For example, additive solutions might be easier to process in our mind. We may view additive solutions more positively, because the more, the better. There might be more opportunities for adding than for subtracting. We may feel less creative while removing something. Or we may assume that existing features are there for a reason, so we don't want to remove them. And we may not want to remove those features, especially if they took effort to create in the first place. So we have this sunk cost bias. And last but not least, subtractive solutions may be less appreciated in our organizations. So what can we do? Can we do anything? Yes, we can introduce countermeasures on both organizational and individual level. And from those problem-solving experiments, we know about 3 countermeasures that should be effective. And first example of such countermeasure are so-called predefined sunset clauses. So clauses that automatically trigger some subtractive solutions. An example of that in our context might be some predefined metrics that need to be fulfilled or not fulfilled to trigger some subtractive solution, like for example, to stopping developing or maintaining some part of our scientific software in our company. The second example of such countermeasures is to explicitly mention, discuss, solicit, and value proposal for subtractive solution, because it helps to come up with a subtractive solution. And finally, we need to remember that we commonly use additive solutions by default if we are cognitively loaded. So we need to give ourselves time to step back, see the big picture, look at the problem from different perspectives, maybe work on some proof of concept before rushing to implement something in the production code. And this approach is also known as making important architectural decisions in the latest responsible moment. So in the moment when we have all the information we need to make the optimal architectural decisions. So to sum it up, very often adding something might be good enough for our scientific software architecture, but it might pay off to constantly reminding ourselves that removing something might be even better. Thank you.